Okay, so we're going to quickly go over acid-base balances, and general info is that your pH goes from 7.35 to 7.45, that's the happy state, and your arterioles is usually 7.4, your SF is 7.35, and if acids are things that release hydrogen. If it's volatile, it can like leave the solution as carbon dioxide. If it's fixed, it doesn't leave the solution, and you can only get rid of it through renal mechanism. So base is that you have an OH or you accept the hydrogen. So there's three systems. There's the chemical acid-base buffer system, there's the respiratory system, there is the renal mechanisms for the balance systems. In the chemical ones, these ones act out immediately, and they're proteins, phosphate, bicarb. So proteins is the most abundant. It's present in the red blood cells, plasma, ICF, and bicarb is very important in the ICF and the ECF, and it's the only buffer in the ECF because phosphate is not present in the ECF. Phosphate is only in the ICF. Okay, so bicarb, it only functions right when the respiratory system is working. It's limited by the size of bicarb. Okay, so then the respiratory, if you remember, CO2 plus H2O, you have like carbonic anhydrase, that turns into H2CO3, that turns it to HCO3 plus hydrogen. So the CO2 is expelled from lungs. Hypercapnia results when you have like too much carbon dioxide, and it takes about 1 to 3 minutes for the respiratory buffer system to work. But it's like more powerful than all the chemical buffer system put together. So what if your respiratory and your chemical doesn't work? Well, you have the renal mechanism to buffer. And it's also the only system that can dispose of fixed acids. And it can vary the rate of hydrogen secretion and the rate of bicarb secretion. And basically, you can generate new bicarb in the bicarb reserve. And if you know, bicarb is only one in ECF, very important. You could either get it through glutamate. It oxidizes the amino group to 2-ammonium, which goes to the filtrate, and 2-bicarb, which goes to paratubular capillaries. Or you can excrete buffered hydrogens, H2O plus CO2, H2CO3 goes into H, and it's HCO3, and it's buffered by like HPO4, that kind of thing. So what happens when you have like when you have acid-base disorders? Very simple. I can go through it with you. So you would check a patient's pH to see if they do, if you suspect that they do. If it's lower than 7.35, then they have acidosis. You want to check their PCO2 next to see whether they have respiratory or metabolic. And if they have like an increased rate in PCO2s, then it's probably respiratory. So the renal mechanism is going to kick in at this point to excrete hydrogen and increase reabsorption of bicarb to try to get the pH up to normal values. And if the PCO2 is normal, then you know that it's metabolic acidosis. So respiratory acidosis is the most common. It's caused by hypoventilation, where you don't like breathe out as much. You have like increased level of PCO2s. Whereas metabolic acidosis, it's well, anyways. And then if your patient's pH is above 7.45, they have alkalosis. It's either respiratory or metabolic. So again, I check for PCO2s. So they have a really low PCO2, that's probably respiratory. And it means that they're hyperventilating, they're having an anxiety attack. If they have a really high one, if there's normal, then it's probably metabolic. And alkalosis can be caused by if you like swallow too much Tums. that kind of thing. So